Now then, also I believe that P over G is not listed in your book. I guess that's why I wrote this down. But if he asks you something where he says, please give me P, I'll give you G, when you look in there you won't find it. All you got to do is look around till you find a couple of things that'll give you P over G. You have a P over A, that gives you the P you need in the top. You have an A over G, that would give you the G in the bottom. The A cancels the A, so if you multiply this factor in the table times this factor in the table, you'll get the factor you want, P over G. Could we have agreed that G started first year? Yeah, we've already discussed that. All right, finding the present deposit necessary to yield a given gradient. Question, how much money do I need to invest today at 6% so that you could withdraw no money at the end of year 1, $100 at the end of year 2, $200 at the end of year 3, and so on. And then $600 at the end of year 7. That will be a gradient problem. The gradient is $100. The number of years this thing is going to go on is for 7 years at 6%. So you multiply your given G of $100, 0, 100, 200, 300, 400, 500, 600, 700. No, it goes to 600. And you'll find the factor in the tables is 15.4497. Saying that you would be able to, you would have to invest $1,544 today in order to have that cash flow in gradient fashion. Oh yeah, I was just checking this out. Okay. Note also that if you want G, and if the tables didn't have P over G, yours do. We just proved that. We just found it. But you could instead multiply G times P over A times A over G. If you go check these factors in the book, you'll find the P over A factor for 6% 7 years is 5.5824. You'll find that the A over G factor is 2.7676, which get together and still give you $1,544. Alright, finding the future value if you are able to cough up out of your earnings a steadily increasing stream of deposits. How much money could we take out of the bank after 5 years if we're willing to invest $100 today, $200 at the end of the first year, and so on? Answer would be found by using this factor out of the table or the equations for this factor. You're given the G, so that goes on the right-hand side of the equation. You want the F. To get that, you'd multiply times F over G. G would cancel G, leaving F. But, ooh, look what he did to us. He cheated. He says he's going to invest $100 today. Why, that wasn't very nice. If he's going to invest $100 today, then he's not using standard form. He says he's going to invest $100 today. I tell you what, rather than putting $100 today, let's just pretend the 0 is here. There's $100 today. And then he's going to give me $200 at the end of the first year. So this is $100. This is $200. Going to give me $300, going to invest $400, going to give $500 at the fourth year, going to give $600 at the end of the fifth year. So this is the way we're talking about time. Do it today is 0. That would be the end of the first year, into the second year, into the third year, into the fourth year, into the fifth year. Tricky, tricky. Now then, you will not be able to use your standard tables because unfortunately the world has not agreed to set up a table for your use where today you put in $100. In order to use the tables, you must say 2 years ago he thought about investing some money. At the end of the first year he just hadn't had the gumption to do it. And at the end of the second year, he actually put in 100. So, what you'd have to do to work this problem is you can use these tables, but unlike the numbering scheme listed in the problem and trying to trick you, 0 through 5, you will have to admit that this is the numbering system used in the derivation of those tables. And therefore, you would use G would be 100. That's okay. You'd use the F over G table. That's okay. You'd use the 6% interest table, but then N for use in the tables is not 5, as I'm sure the answer will be in there. You can be pretty sure that answer would be one of the ones listed. You'll have to use 7, because that's what we have agreed in the derivation of the tables. And indeed, that's what it says here. Here's the $100. Unfortunately, he's got 2 traps in this one. He doesn't have a table for F over G. I mean, he doesn't have a column for F over G. So in order to get F over G, in order to get this F and this G in the bottom, you're going to have to use the F over A table, and you're going to have to use the A over G table, multiply the 2 together. The A will cancel the A, leaving you with F over G, which is what you want, and you'll notice the 7-year, not 5 years, as he's trying to trick you into thinking. You multiply those factors together, you find that if you make those cash investments in that fashion, you would be able to extract $2,323 at the end of that time. Now, in this case, we're kind of doing the same thing as we did before. We ran a $100 gradient up between times 0 and 7. The p-value we found here was $1,544 for that gradient. And the present value, and the future value we found for that same gradient right above here is $2,323. And if that's true, then this string of money giving this and this string of money giving this, then this ought to be the same as this, ought to be equivalent. So let's just see what the future value of this is and see if it comes out this. If P is $1,544, you'd use the F over P column, 6% year, 6% interest, 7% row, 7-year row. You find the factor is 1.5036, and it does indeed give the same amount within reasonable accuracy. So all 3 of these cash flows are identical. Which would you like? I don't care. Give me $1,500 now. Give me a $100 gradient in the agreed upon fashion, or give me $2,323 at the end of 7 years, and I don't care which one you give me. They're all the same, assuming that I'm willing to loan money at 6%. Obviously, if I'm desperate to buy a $1,500 computer today, then I'd much rather have the $1,500 today than the $2,323 later. All right. Find A given G. In other words, what annuity, when invested on a regular basis, would allow me to extract from the bank a gradient withdrawal pattern? If I'm able, find A given G, actually this works the other way. In other words, what money would I have to put into an investment to be able to withdraw a constant amount? If I go to the bank and I say, look, I really need this money to be withdrawn from your bank. I'm going to make a pot full of money, and I will be able to put money back in your bank on a regular basis, but I won't be able to give you much at first, but at the last, I'll be able to give you a whole pot full of money. He says, well, all right, I will allow you to extract some amount of money from my bank at 6% for 7 years if you're willing to pay me back in gradient fashion with an amount, $100 at the end of the second year, $200 300, 400, 500, and 600. And I want to know what A is. When you do that, exactly like